Beat. We spend so much time looking at AI benchmark scores.
Yeah, we really do.
We stare at these massive, complex leaderboards. We compare the abstract math scores.
hmm
But we often forget to ask the only question that actually matters. 2-sec silence. What happens when you finally put it to work?
That is the real test, honestly. The real world is remarkably messy.
Right.
Benchmarks are just sterile laboratory environments. They measure raw potential, but they never actually measure execution.
Execution is our mission today. Welcome to the deep dive. We are putting a highly anticipated model through a rigorous 5-part gauntlet.
We really want to see if it survives the mess.
Hmm?
Today, we're looking closely at GPT 5.6 Sol.
That's the flagship model of the heavily discussed Fable 5 generation.
Yeah, and Fable 5 is getting serious attention in the industry right now.
It really is.
It can navigate ambiguous, multi-step reasoning without requiring a human safety net.
We're moving completely past the theoretical today. We're going to examine 5 incredibly specific, real-world use cases.
Massive spectrum of cognitive capability.
Exactly. We'll explore HTML design, autonomous sales pipelines, and blank page website creation. We will also tackle the absolute geometric nightmare of fixing PDFs. And finally, we'll look at managing multi-model workflows.
We are testing visual design, automated research, rigid documentation, and pure logic.
But before we jump into that first visual test, let's establish the baseline context.
Right, the pricing tiers.
Yeah, GPT 5.6 actually comes in 3 distinct tiers. First, you have Luna. That's the lower cost option built for lighter text tasks.
It runs at about 29 cents per run.
Luna is great for generating a quick, dirty draft,
Right, and then you step up to Terra. That's the middle option.
which costs 37 cents.
Yeah, and it provides much more structural stability.
And then we finally reach Sol. This is the strongest tier available. It's heavily optimized for deep reasoning.
And it runs at 90 cents per task, so it's roughly 3 times the price of the Luna tier.
This central question of this deep dive is whether that premium is actually justified.
Exactly. Does paying 90 cents upfront save you $10 of human labor later?
Let's find out. We're starting with a deeply foundational task.
HTML generation.
Right, that spatial logic we see every day in polished visual products.
So the first test they ran was generating an HTML presentation slide.
And the instructions were incredibly strict.
Very strict. It had to create exactly 2 presentation pages. It needed a strict 16 by 9 widescreen layout,
It had to follow the provided brand colors exactly.
including a very specific gradient.
Yeah. It also required embedded CSS and JavaScript. Embedded CSS styling rules written directly inside the web page file.
The layout had to demonstrate a clear visual hierarchy, and the company logo had to sit exactly in the bottom left corner.
It's a rigidly defined design test. No external styling libraries were allowed unless absolutely required.
And the prompt explicitly demanded perfect factual accuracy, no adding claims, no arbitrary numbers.
Absolutely no hallucination was allowed.
Right.
Hallucination, when the AI confidently makes up fake information.
Precisely. So they ran this identical prompt across all 3 model tiers. They used the exact same project files.
Kept it completely objective.
Yeah, totally fair comparison.
Well, Luna handled the basic text generation perfectly well. It even got the brand colors right.
But the final design just looked far too simple.
It felt empty, almost like a wireframe sketch.
Then they tried Terra. It cost slightly more than Luna, but the visual layout didn't feel clearly better.
The spacing between the text blocks actually looked unbalanced.
Yeah, it felt clunky and unprofessional.
But then came the Sol model. Sol delivered a highly polished, presentation-ready result.
It kept the text completely accurate to the source material. It followed the requested color gradient perfectly.
Used much cleaner negative space between the elements.
The visual hierarchy was immediately obvious to the human eye.
The headline stood out beautifully against the background.
The call to action was incredibly easy to notice. And the logo was anchored correctly in the bottom left.
All of that for 90 cents.
Yeah.
Speed. I have to make a vulnerable admission here.
Oh.
I still wrestle with settling for rough AI drafts and wasting hours tweaking them myself.
You're definitely not alone in that frustration.
I just convince myself it's faster, but it never is.
We often accept a weak first draft because it feels like forward momentum.
Right.
But then we accidentally become full-time editors. We end up spending more time fixing the AI's structural mistakes than if we just started from scratch.
It completely defeats the purpose of the automation. If I have to fix the margin spacing manually, I am not saving time. I'm just changing my daily job description.
Right, and a rough presentation draft simply creates another editing task.
Exactly.
Sol gave a surprisingly strong first version. It acts as a competent partner, not a burden. It significantly reduces the manual pixel pushing you need to do later.
I am hung up on one thing here, though. Predicting the next word in a sentence makes intuitive sense to me.
Sure.
But why is layout so much harder for an AI than writing text?
It fundamentally comes down to structural architecture.
Yeah.
Language models are built to predict text in a straight linear line.
Right.
But graphic design requires deep spatial logic. It requires understanding visual weight and negative space on a broad canvas.
It's not just a sequence.
No. Instead of stacking words, think of it like an architect working with a physical floor plan.
That makes a lot of sense. The model has to calculate the gravity of the page.
Exactly. It knows a heavy, dark logo in the bottom corner needs breathing room.
Mm-hmm.
It needs negative space around it to keep the whole canvas from tipping over visually. It calculates the visual tension between the text blocks and the imagery.
So design requires spatial reasoning, not just predicting words.
It's a completely different cognitive muscle for the machine, and Sol clearly flexed it well.
From spatial layout, we move straight into chaining data logic together.
This is a big one.
We're talking about connecting deep research, complex scoring, and targeted outreach in one continuous flow.
This brings us directly to the second use case, connecting a platform like Clay to the model.
Clay acts as the data extraction engine.
Right. The core goal was to build a highly qualified, automated sales-led list.
The target criteria they set was highly specific. The model had to find U.S. fintech companies.
They needed to have Series B funding.
Series B funding, the second major investment round to scale business operations.
Perfect. They had to have exactly 50 to 200 employees.
They also needed to show a clearly defined sales team.
And display very recent signs of corporate growth. Things like recent venture funding, aggressive new hiring, or territorial expansion.
The model had to find the company and confirm those complex details. Then it had to hunt down the specific VP of sales.
It had to get a completely verified email address for that exact person.
But the autonomous workflow didn't stop there.
No, it had to score that specific lead. It assigned a score from 1 to 10.
This was based on a very specific ideal customer profile.
The ideal customer profile looked for companies handling large amounts of data, companies that could genuinely benefit from automating their operations.
The model had to logically explain that score in one short sentence.
And then it had to write a custom first-touch email.
That email had to reference those exact recent growth signals it just found.
Any company failing that strict filter had to be removed entirely.
The final results were genuinely impressive. Sol successfully built the entire complex lead table.
It returned 5 specific accounts with highly qualified scores from 8 to 10.
It returned the complete actionable package. It grabbed the company name, employee count, and the latest funding rounds.
It even found the contact person and verified their direct email.
The outreach emails were highly customized and conversational.
They referenced specific growth signals and likely sales needs for each unique company.
It felt incredibly natural. 2-sec silence. Whoa. Imagine scaling this to analyze thousands of companies in seconds.
The sheer velocity of the workflow is staggering.
It really is.
What used to take a dedicated sales research team a full, exhausting week is now a single automated prompt. It processes the entire pipeline instantly.
But I want to pause and challenge this a bit. With all this automated research, how much do we actually trust the verified emails and funding data?
That is the most critical question of autonomous workflows.
Yeah.
AI can still pull heavily outdated data from stale databases.
Right. People change jobs frequently.
Funding rounds get misreported in the press. An experienced human must do a final spot check. You cannot blindly trust the machine.
Trust the initial filter, but verify the final facts before sending.
Exactly. You use the AI as an incredibly fast intelligence analyst. It sifts through the massive mountains of irrelevant data. But you still must inspect the final target list yourself before launching a real campaign.
We've seen Sol follow incredibly strict visual and data instructions. Now, what happens when we give it a completely blank page and ask it to make creative decisions?
That takes us right into the third use case, building a complete one-page website from scratch.
The prompt simply asked for a web design service aimed at small businesses.
The main goal was to encourage visitors to book a free consultation.
The target audience was small business owners who completely lack an in-house developer.
The structural requirements were laid out clearly. It needed a strong hero section,
A section explaining common small business problems with outdated websites.
A dedicated services section. A simple process section explaining how the project actually works.
It also needed a portfolio section with 3 sample project cards.
A social proof section focused heavily on practical benefits.
Clear pricing options. And a final, highly visible call to action.
The design direction simply requested a clean, modern style. An open layout that is exceptionally easy to scan.
And bento-style content blocks.
Right.
Bento-style blocks. Neat, grid-like square panels seen on modern dashboards.
It also needed smooth scrolling and responsive design for mobile screens.
Now, a blank page is completely terrifying for most generative models.
Oh, absolutely.
But Saul made excellent independent design decisions. It chose the typography combinations entirely on its own.
It dynamically chose the bento card shapes.
It decided on the internal padding, margin spacing, and color palettes.
It created a highly visible, contrasting consultation button. It even coded a browser-style visual graphic that made the digital service feel much more real.
It turned the main customer problems into 4 easy-to-scan, beautiful cards.
And it did all this without needing step-by-step design hand-holding.
Right. It created a serious structural first draft, not just a rough visual mock-up.
The page obviously still needs real portfolio examples inserted later.
Of course.
It needs your final pricing numbers and heavily tested booking links. But the foundational web design is completely solid. It bypassed the empty screen problem completely.
I'm still trying to wrap my head around this. How does the model avoid blank page paralysis when it isn't given exact hex codes or fonts?
It uses deep underlying structural logic. Saul analyzes millions of modern websites during its initial training. It implicitly understands modern industry conventions. It knows how a bento layout should function visually and mathematically.
So it just fills in the gaps.
Yes. It fills in the creative gaps using established aesthetic patterns.
It leans on industry patterns to make those unprompted creative choices.
Precisely. It understands the underlying grammar of modern web design.
Right.
It knows that a heavy sans serif header pairs perfectly with 24 pixels of margin space. It knows what looks good because it intimately understands the statistical patterns of good design.
Saul can build a beautiful website from a blank canvas. But can it handle the rigid, universally frustrating world of government PDFs?
This is where automated data entry usually breaks down completely.
Yeah. Manual government forms create endless, frustrating systemic errors.
A test here was filling out a completely blank W-9 form.
They used simple dummy data for the test. Name, business name, federal tax classification, and the physical address.
They also included a dummy taxpayer ID number, a TIN.
The model had to place every single text value exactly inside the correct visual field.
It had to intentionally leave the signature and date fields entirely blank.
Then it had to check that every value was perfectly inside the correct box.
It had to autonomously fix any misaligned text. And finally, save it as a specific PDF file.
PDF forms are notoriously easy for machines to completely misread.
Very true. A business name lands awkwardly in the wrong field. Important numbers shift slightly out of place.
One small geometric mistake makes the final document look incredibly unprofessional.
And that problem scales terribly when you repeat the task across thousands of files.
The results here were fascinating to look at. Saul correctly identified the official W-9 form.
It placed almost everything perfectly right.
The name and address were perfectly situated in their boxes.
However, there was a tiny, frustrating glitch.
Just one.
Yeah. One single part of the taxpayer ID number didn't sit cleanly inside its tiny box. It was slightly misaligned geometrically, bleeding over the line.
But here's the truly interesting part. After receiving automated feedback, Saul readjusted the number's position.
It successfully saved a much cleaner, perfectly aligned version.
It actively fixed its own spatial error.
The final form looked highly polished and professional.
But the tester rightly noted, it still required that final human review before actual production use.
Always.
Why does a highly advanced model stumble over aligning a few numbers in a PDF?
Because PDFs are not fluid dynamic text documents. They act more like rigid visual coordinate maps.
Right, they are static.
Placing text exactly inside a tiny box is a complex geometric challenge. It is not about reading comprehension. It is about plotting coordinates precisely on a strict X and Y grid.
PDFs are visual maps, making text placement a geometric nightmare.
Right, and legacy government forms were never designed for modern machine readability.
No, they were designed for typewriters.
Exactly. They are essentially digital photographs of paper documents. The AI has to mathematically guess where the invisible boxes actually begin and end.
We have seen Saul work completely alone across visual design, sales research, and complex forms.
Hmm.
Now, let's look at the ultimate test of autonomous logic. Saul managing and critically reviewing another AI model's work.
This takes us to the final, most complex test, a multi-model automated workflow.
Giving each model a completely separate, distinct role to prevent systemic bias.
Model 1 steps in first. It reads the complex project file.
It reads the historical documentation and the test suites.
It writes a detailed problem summary. It creates a technical plan to fix the software issue.
It explicitly lists every underlying assumption used in the plan.
Crucially, Model 1 is explicitly instructed not to change any files yet.
Right. It simply creates the architectural blueprint. It proposes the technical changes for review.
Then GPT 5.6, Saul steps into the workflow as the senior reviewer.
It independently compares Model 1's technical plan with the actual code base, the tests, the documentation, and the current database.
Saul's job is to ruthlessly hunt for logical bugs.
It must catch missing steps and identify outdated instructions.
It must clearly explain why each identified issue actually matters.
It marks every finding as critical, important, or minor.
And it has the absolute power to block the approval entirely.
So what actually happened when they ran this workflow?
Saul reviewed 6 dense project files.
And it marked the entire workflow as blocked.
It found highly critical bugs in the June 2026 financial data.
Model 1 had completely hallucinated some math and severely miscalculated the company's revenue.
Model 1 completely miscalculated the monthly recurring revenue.
MR, predictable, recurring monthly revenue from active customer subscriptions.
Model 1 estimated the MRR at $4,450.
So immediately caught the glaring error.
It mathematically recalculated the correct MRR as just $600.
But also forcefully corrected the average revenue per active customer.
It brought the calculated average revenue down from $890 all the way to $120.
How on earth did it find that massive discrepancy?
Saul caught a fundamentally bad cancellation date rule in the code.
Wow.
Model 1 misunderstood when a customer technically churns based on billing cycles.
It oversubtracted annual revenues incorrectly.
The billing rule didn't match across the actual code, the tests, the RADME file, and the project documentation.
Saul also found that annual subscription plans were incorrectly added at their full yearly price instead of being properly prorated.
And the churn metric used the completely wrong active customer count.
It rigorously checked Model 1's assumptions instead of blindly accepting the technical plan.
It firmly rejected the incorrect cancellation rule.
The workflow stayed safely blocked until everything followed the exact same mathematical rules.
It successfully stopped a completely disastrous financial deployment.
It caught both subtle coding mistakes and glaring project conflicts before any development continued.
Yeah.
I do have to ask, though, why use 2 different models at all?
It's a fair question.
Why not just have Saul plan the update and review the code simultaneously?
Because language models inherently develop massive logical blind spots. Separating the creation from the critique prevents the AI from being blind to its own logical errors.
I think.
A single model will constantly justify its own mistakes because it strictly follows a single, unbroken thread of logic.
Splitting roles stops the AI from grading its own homework.
Precisely. It creates a necessary adversarial check in the system. It forces the creative model to rigorously prove its logic against an independent, unforgiving auditor.
We are going to take a quick break, and then we will synthesize what all this means for you, sponsor poor. And we are back. Let's pull back and look at the big picture here.
We have covered a massive amount of technical ground today.
When we synthesize all these diverse findings, the core takeaway is actually about smart resource allocation and trust.
GPT 5.6 Saul costs roughly 3 times as much as Luna.
90 cents versus 29 cents.
But that 90 cents is a direct investment in systemic autonomy.
For simple single-step tasks, you should absolutely use the cheaper models.
Luna is perfectly fine for generating a quick text draft.
But for multi-step workflows, the calculus changes dramatically.
When you need strong historical context.
When you need complex autonomous decision-making.
When you rely heavily on deep structural logic.
Paying a few extra cents for Saul makes perfect economic sense.
It drastically reduces the manual human labor required to fix frustrating mistakes later.
It fundamentally changes our psychological relationship with the machine.
It shifts our professional role from tired editors to strategic directors.
We finally stop fixing margin spacing and frustrating typos. We start guiding the larger structural outcomes and business strategy.
Exactly.
Before we wrap up this deep dive, I want to leave you with a lingering thought.
hmm
We saw Saul independently review another model's code today.
We saw it seamlessly recalculate complex recurring revenue with absolute mathematical precision.
We saw it outright block a bad workflow that would have severely corrupted financial data.
Yeah.
If Saul is already capable of doing all of this autonomously, if it can catch subtle logic errors that most junior developers would completely miss,
Right.
how far are we from a future where AI handles the entire project lifecycle?
A future where human beings are just the final signature on the approval form.
It is a profound, slightly unsettling shift in how we work. I want you to actively think about your own daily workflows this week.
Look at the rigid, highly manual tasks you are still doing right now.
Which of those could easily be handed off to a multi-model autonomous review tomorrow?
The foundational tools are already sitting right in front of us.
It is just a matter of how we purposefully choose to apply them to our own friction points. Thank you for joining us on this deep dive. Stay curious, keep exploring your own workflows, and we will catch you next time.